going to introduce differentiation in calculus now. You've seen James Bond jumps out over the crevice and then his parachute open. So it's a James Bond movie, obviously, The Spy Who Loved Me. Alright, so we have a problem. He can only jump when his speed is equal to 25 meters per second. And we're going to try and solve that problem now. Now, this is the way he moves. This is the equation. So what does it mean? The x stands for the number of seconds. I've tried to show you here. And the fx is the y. Y is equal to that. So this is, the input is the number of seconds. The output is the number of meters. So when I put in 1 second, he's moved 2 meters. If I put in 2, it's 8. 3 times 3 times 2 is 18, and 4, let's have a look at 4. 16 times 2 is 32. So, James Bond, his speed must be 25 meters per second. So, when can he jump? That means when is an x. So, let's look at his speed at 3 seconds. At 3 seconds, he's gone 18 meters. Speed is distance over time. Sorry? Okay. Right. So, what happened? 18 to 32. So, he went so many meters, which is 14. But how long did it take? 4 minus 3. So, it's 14 meters per second. So we can see it's not at 3 seconds, né? He must still ski a little bit. We know between 3 and 4 it was 14 meters per second. Okay, so what I'm going to do now, I'm going to approach the 3 seconds. So 4 seconds is 3 plus 1. Now we're going to take between 3 and 3.5, which is 3 plus 0.5. And then now we're going to take 3.1. So it will be 3.1. So as you can see, I'm making this thing I'm adding smaller and smaller. Okay? Right. So the speed is distance over time. So what is the distance there? What is the distance there? This is the difference in the time. That is the speed. At 3.1, the distance is that. At 3, it's 18. We get the distance. We divide it by the time. So now we can see it looks like it's going to 12, okay? But I don't know exactly what is the speed at 3. So here we introduce a variable for 1, 0.5 and 1. We see it's getting smaller, so we're going to call it h. And h is going to strive towards 0. Okay. When we then get the exact speed at 3, we're now going to say 3 and 3 plus h. Remember, we make it smaller and smaller, so it approaches the point where x is 3 seconds. So we want to know the real speed. Okay, so speed is distance over time. So I put in 3 plus h, I find the distance, f3 plus h, you put the x, the 3 plus h in the place of the x. So this is what happens. And then you put the 3 in. Alright? So I work this out. This is very difficult for students. This is a binomial square. It's this square plus 2ab plus b squared. Né? You times it out and you see what is left. The h goes into there, the h goes into there, you get this. But this is just the speed. So the real speed will be when we let h strive towards 0. So So the real speed is 12 meters per second. And now we're very close to what we want to do. So we've looked at the speed at 3 now, and it wasn't going fast enough. So let's look, what is our problem? We want to know x. X is the unknown, x is the time. So let's say the distance and the time is at x and at x plus h. And then we can find out what is x. We can always find out what is our unknown. So at x, this is his distance, f of x, at x plus h, the f of x plus h. So, distance over time. This is the distance minus the distance over the distance in time, h. I get the square, there it is, I multiply the 2 in, I subtract that and that, I divide the h into there, and into there, I get this. But now the real speed is when h is striving towards 0. So I get 4x. This was the function. So now we're doing the real speed. H is striving towards 0, we got 4x. But we said James Bond must move at a speed of 25 meters per second. So 4x is equal to 25. Therefore, if we want to work out x, 25 divided by 4, it's 6.25 seconds. So after he's gone 6.25 seconds, he can jump. Now, what are we doing when we differentiate? So when you are differentiating, you're getting the real speed. That is very important. So you are creating a new function. And the output of the function is the speed. The output is the speed. And how do you get it? This is the rule that they teach you at school. So n, there's a 2, the n is 2, so it comes forward, x, 2 minus 1. So we get 2 times 2 is 4x to the 1. So you can already you can differentiate anything by using this rule. Okay, what I want you to remember is that when you differentiate, you are getting a new function, which is the rate of change. In James Bond's case, the meters, the y, the x was the second. So it's meter per second, it is actually the velocity. Depending on the 2 units that we have, we're creating a new function that gives us the rate of change. And this is the rule you are going to use. The function is xn, the derivative, which is indicated by fx and x, is nxn minus 1. That is your standard rule. You'll see in the cards, we put all your differentiation formulas in there, and we gave you the different derivatives of the trig functions as well. So the derivative of sine x will be cos x, the derivative of cos x is minus sine x, and so forth. So you have all the tools. So please go and enjoy doing the sums on differentiation and integration in the maths cards.